come on video.
Sure.
Yeah.
Srinath sir.
I have started recording.
Okay. And YouTube? Beautiful. Sir, Srinath sir, can you just come over in the video?
Yeah. I started my
Yeah.
video. Can you see me?
Yeah.
Okay.
Yeah.
Yes, sir. Thank you. Yeah, Akila, Dr. Akila, you can start.
Yes, ma'am. Good evening to all present here. I welcome you all for this webinar on artificial intelligence and responsible autonomy. It's about who we are and not what we do. I welcome today's session.
Akila, your
Mr.
net is not okay.
Website Club,
Your voice
Indian
getting broken.
Information Technology, and all the eminent people over here and all the participants. First, I request Mr. H.R. Mohan sir, Chair Events IEEE CS Madras, to welcome the gathering and also introduce the speaker.
Greetings and good evening to one and all. On behalf of the organizing unit, CSI, IEEE Computer Society, ACM, I extend my warm welcome to our today's eminent speaker, Dr. Srinivasa, members and my colleagues from the organizing unit, and the participants who have joined the webinar through Google Meet platform and both watching the YouTube streams. With the developments in AI, more power is available to people to carry out many things precisely and instantly, which otherwise would have taken several hours or days. Further, the recent release of the DeepSeek AI foundation model, considered as good as the paid version of some of the well-known models of OpenAI and Google, as an open source application and being made available at a fraction of the cost to the developers makes abundant power is made available to people overnight. This power is considered as double-edged sword and could be effectively harmful to the society if not used in a responsible way. Our today's presentation is all about responsible AI and its agentic application. The webinar presentation will start with an introduction to the agentic AI and the challenge of multi-agent system and the ethical questions they pose. With agentic AI entering different application areas, responsible autonomy is of urgent concern. Several paradigms of responsible autonomy have been addressed in the literature, coming from different philosophical schools of thought. However, one common assumption across much of the approaches is that responsible behavior is considered to be necessarily in conflict with the autonomous choice of the agent. In response to this, the responsibility layer of autonomous agent acts as a constraining layer that either prevents certain actions from being performed or provides negative reinforcements. The speaker will elaborate on his group's work called computational transcendence, how the responsible behavior need not necessarily in conflict with autonomous choice. Their mathematical modeling of an elastic sense felt into autonomous agent and show that even little bit of elasticity with agent identifying only with their intermediate neighbors can result in vast improvements in responsible autonomy. This presentation will conclude highlighting the application areas involving multi-agent flow networks, such as supply chain and vehicular traffic control, and show how to incorporate computational transcendence in these networks to improve the flow. So with this basic introduction about the topic of presentation today, now let me formally introduce the speaker with whom I got connected recently, as both our interests in areas such as web, edtech, SDGs, social responsibility, etc. are in sync. In a short time of our connection, she was very supportive in few of our activities of IEEE. Incidentally, we also have the same alma mater, IIT Madras. Dr. Srinath currently heads the Web Science Lab and is the Dean of Research and Development at the International Institute of Information Technology, Bangalore. He holds a PhD from Berlin Brandeis Graduate School for Distributed Information Systems at Germany, and MS by Research from IIT Madras, and BE in Computer Science and Engineering from National Institute of Engineering, Mysore. Dr. Srinath's research interests are in the areas of web science, understanding how the World Wide Web is affecting humanity, and how the web can enable social empowerment and capability building. He has participated in several initiatives for technology-enhanced education, including the EDUSAT program by the Visvesvaraya Technological University, the National Program for Technology-Enhanced Learning, that is popularly known as NPTEL, the Switzerland-based online MBA school called Educatis, and IIIT-based educational outreach program with Upgrad. Dr. Srinath has served on various technical and organization committees for international conferences such as International Conference on Weblogs and Social Media, ASEAN Hypertext, International Conference on Management of Data and Data Science, and International Conference on Ontologies, Databases and Applications of Semantics, International Conference on Big Data Analytics, ASEAN Web Science, etc. As part of academic community outreach, Dr. Srinath has served on the Board of Studies of Goa University and as a member of the Academic Council of National Institute of Engineering, Mysore. He has served as a technical reviewer for several journals such as BLDB Journal, ACM Computing Surveys, Springer AI Ethics, IEEE Transaction on Knowledge and Data Engineering, IEEE Transaction on Cloud Computing, etc., to name a few. He has served as an associate editor of the journal Sadhana from the Indian Academy of Sciences. Dr. Srinath is a recipient of several national and international grants and awards from foundations and companies like European Union's Horizon 2020, UK Royal Academy of Engineering, Research Councils of UK, MEIT, DSC, Siemens, Intel, Emphasis, EMC, and Guru. He has also led the AI initiatives for the Karnataka Data Lake project by planning the department of the government of Karnataka to promote data and evidence-based planning and decision making. We are really fortunate to have such an eminent person to address us today on AI and responsible autonomy. Now
Hello.
let me welcome Dr. Srinath to take over.
ஆட்கள் உட்காந்துட்டாங்க முன்னாடியும் மெசேஜ் அனுப்பிடுது.
So, yeah.
Participants, please mute. Yeah, thank you.
Okay. Thank you, sir. And firstly, let me express my profuse gratitude to the jointly held webinar supported by CSI, IEEE, and ACM Chennai, and the very enthusiastic people behind this, Dr. Mohan, Dr. Komathy, Dr. Akila. I've had a very good time interacting with them and planning this event. So, maybe I should start by sharing my screen, and we can go ahead with the plan of how to. Let me see. Yeah, I hope my screen is visible.
Yes, sir.
Yes, sir.
Wonderful. Yeah, wonderful. So, yeah, without further ado, I think this is a topic that all of us are very interested in, and this is very timely. Even as we speak, lots of things are happening in the field of AI, and lots of doomsdayers are talking about it. And of course, the latest thing is the DeepSeek, issues that are coming up, and so even as we speak, I'm sure by the time I finish the talk, from the time I start the talk, a lot of things would have changed in this field of AI, right? And so this is the tsunami that's kind of coming towards us, and it is having a lot of opportunities, a lot of disruptive opportunities in the way we basically lead our lives, both the way we conduct business, or the way we conduct governments, or even our personal lives, and also a lot of dangers that we can't even imagine, right? And even as we are coming to terms with AI as we understand in the terms of LLMs, foundation models and so on, a new thing has started called agentic AI, right? Which is now kind of taking over its own way, right? And and agentic AI brings yet another layer of sophistication or complication, I should say, to this entire picture, right? And so we were talking of responsible AI so far, and now suddenly we also have to talk about responsible autonomous AI, right? And so let's look at what this field is about and how it has evolved over the years, right? And, okay, is there a way I can? One minute, let me. Yeah, got it. Good. So let me start my talk with the right acknowledgements, because really I'll be talking about some of our research work. I'll be talking also about. I'll start with a brief overview of the bigger picture of responsible autonomy, but and also doing some amount of deep dive into our own research in this area. And really, the primary drivers behind this research are the young, bright faces you see on the slide here. So part of this work derives from the thesis, from one PhD thesis and 4 IM.Tech thesis, M.Tech thesis from, and you see the project students over there. So out of these, Jayati is now doing a postdoc at the University of Southampton. Karthik is doing his PhD at Leuven, University of Leuven in Belgium. Janvi is in Microsoft, and Nikita is in Google, as I know, right? And and really, all the credit should go to them for all the nitty-gritties of this work that has taken. We also interacted with Professor Raghava Mutturaju and his PhD student Aisha Ejaz from IIIT Delhi. Part of that interaction also helped us enrich our own understanding of responsible autonomy. And of course, you'll also see a little bit of existential philosophy as part of this as well. And there too, we have derived insights from spirituality, and especially talks given by Swami Sarvapriyananda, which is very popular on YouTube these days. And a couple of slides I'll probably even also alluding to that. So really the main ideas belong to all of these folks that will be present. Okay, so let us start with agentic AI. I'm sure all of you have heard this trending term these days, that the future is agentic, and there's a lot of agentic AI coming around. There is Langflow, there is Agent GPT, there is all kinds of Microsoft has its own. There's Meta GPT, all kinds of agentic AI, right? And but of course, you also see this recent quote by Jan LeCun, right? Which basically says, just as we are all now starting to introduce LLMs in our curriculum, he's saying nobody in their right mind will use LLMs in the next 5 years. So, that's where we are going. In the sense, basically, if you read the article, it says the future is agentic. That is, LLMs are there, but they're just foundations, and then agents will start doing things on their own, and it brings in a whole new kind of development, a whole new kind of inflections, right? And so we already have a lot of agentic AI around. Of course, we have agentic LLMs. Autonomous cars are there all over. Now, Tesla recently released its own full autonomous vehicle. Waymo has been running autonomous taxis in San Francisco. There's even in India, there is Swayat Robotics who have achieved, they say, level 5 autonomy in vehicles. There are autonomous drones that are already used in warfare. The Russia-Ukraine war, there's a lot of autonomous drones that are used. Algorithmic trading is at least 25 years old, and a lot of stock trading is done by agentic AI for a long time now. So unlike what we believe, agentic AI is nothing new actually. It's at least 25 to 30 years old, and the idea of agency has been developing over the years, and several applications have already come. Swarm robotics, of course, drones, drone shows, and all we see, and autonomous traffic lights. So we already see in many of our cities, it already has these ATLs. I'm sure Chennai also has some places. So they're already entering our lives, right? And in different ways, right? So what is agency, or what is agentic AI? How do we understand agency, right? So if we look at definitions of agents, typically we'll find a definition like an agent is something that acts autonomously, right, on its own. So and that's how we started with understanding agency as well, right? I remember that computational agents started becoming seriously considered by researchers sometime in the early 90s, where agents primarily meant that objects that have their own thread of execution and they can work on their own, right? And there are a lot of analogies also. For example, if you take an LLM today with the neural networks, and let's say you train it with 1 million data samples for a day or something, and then you just leave it like, okay, so what new thing will it learn, right? So it won't learn anything new, because the neurons are all passive. They're not autonomous. They don't act on their own, right? But you take a human brain and let's say you give it some 100 inputs and go away and come back after a while, and you see that it would have learned many more things, beyond what you presented, right? And because the neurons in our brains are all autonomous. They act on their own, right? And so that's that is one of the first models of agency, which is called self-directed actions. Also called meta-programming, right? And so primarily what meta-programming does is you take a broad specification like a prompt or something, and you have some mechanism by breaking down a prompt into different actions and steps and executing it. So that's what that's one of the definitions of agency. But over time, we saw that that is not actually enough, right? Because, for example, let's say I'm mowing my lawn, and suddenly I lose control and I let go of my lawnmower, and the lawnmower keeps going on its own and keeps mowing the lawn, right? So can I say that my lawnmower is autonomous now, and it's doing something? And so clearly that's not the case, right? And so then there are other kinds of models that say no, autonomy also means that it has to have some constraints, right? It can't mow my neighbor's lawn, for example. Lawnmower should mow my lawn, right? And but in addition, it should have some goals. It should have some plan. It should have some world model, right? And so these are what are called normative models of agency, right? And so especially BDI, beliefs, desires, and intentions, right? These were some of the models that were very popular, and it's still widely used in the design of swarm robotics. BDI and other kinds of normative models developed over the years. So primarily, agents here mean that they operate on their own, but guided by certain kinds of goals and plans and beliefs and so. Okay. But then later on, we saw yet another paradigm of agency coming in, that it says that, okay, we can't have static plans. We can't have static, workflows. Agents, because agents work in very different environments. Each environment is different. So agents have to be adaptive, right? So it has to learn from the environment on an ongoing basis, right? And so that's where we saw different agentic models that based on RL, right, reinforcement learning that have come about, which continuously listens to the environment, gets feedback, and updates its plans, updates its goals, and the goal may be the same, but the plans keep getting updated, right? And that's okay. But then even reinforcement learning, we see that it's not enough to capture the whole of what we understand by agency, right? And for example, one might ask that for example, we are all autonomous agents, right? Humans are all autonomous agents. And we can ask that, is all our life just about responding to reinforcements? That is, somebody gives us a reward, we go there. Somebody gives us a, penalty, we don't do that. All our lives, are we just doing this? Or sometimes do we even, neglect the reinforcements, right? And so it does happen, right? And for example, suppose I want something really badly, okay? Then I won't care whether you approve it or not. I'll just go and get it. Right? So basically, we see that an even better marker for agency is rationality, right? So a rational choice. So what is rational choice? Rational choice is basically defined as self-interest plus utility maximization. That is, so when we say we are autonomous, primarily what we mean is we are not acting randomly, we are not acting, we are not just responding to reinforcements, but we are actually pursuing some kind of self-interest, right? So there's a reason why we want to pursue something. And we are acting in a way that maximizes utility towards our self-interest, right? And so we may respond to reinforcements in some cases because it serves our self-interest, and we may ignore the reinforcements in some other cases because it may not serve our self-interest, right? And so clearly, it's the self-interest that is driving the autonomous choice, right? And here we recently wrote a survey on this, looking at the different models of agency, and really one can say that rational choice is some of the most versatile form of agency, right? So today, if we look at complex things, we have a mix of all of this, right? In some sense, I can say that what you see here is, in some sense, a very generic model of agency, where different things come together to make what an agent works like, right? And for instance, of course, we do have beliefs. That is, agents do have a world model, a belief about how the world is, and which it may change. It has a self-interest which it is pursuing, and self-interest is not just a goal. It can be more than a goal, right? It can have several goals within a self-interest, and there may also be external constraints, right? The deontic constraints, and you shall do this, you shall not do this, and so on. All three come together, and agents form a strategy, right? Saying that, okay, this is how I'm going to pursue my self-interest, right? And so based on a strategy, it performs an action, right? And the action yields some kind of payoff from the environment. That is, you may or may not get what you expected, right? And so the payoff, based on the payoff, we get a feedback, and we may adapt, right? So we may curate our actions. So our strategy may remain the same. My strategy would be that, I'll achieve this, and then I'll achieve this, and so on, right? And so our strategy could be the same, but our actions can get curated based on immediate feedback. So this is a typical RL loop that you see, okay? But over time, what also can happen is that if my payoffs are not in line with what my expectations are, I may end up saying that, okay, my belief itself is wrong. My belief about the environment, that this is how the environment works, may be wrong. So I end up performing a belief revision process, right? So once I revise my belief, the entire thing will change. It may in turn revise my strategy, it may in turn revise my action, and so on, right? So this is what's called as an evolutionary game, right? And when all the while the self-interest remains as it is, that is, I could still be having the same self-interest, but my strategy could be evolving, and my actions could be, firstly, my actions could be evolving based on the strategy. Next, my beliefs could evolve based on what payoffs I get. And based on the beliefs, my strategies can also evolve, right? And so all this could happen, right? And in all of these, there are different solution concepts as well. There's a concept of equilibria for one-shot games. There's a concept of stability for what are called rational engagements, right? And there's a concept of evolutionary stability or sustainability, and so on, for the overall agentic loop, right? And so this is this diagram in some sense captures overall in terms of the different elements that go into building a computational agent. Yeah, but our problem today is not about agents per se, right? Our problem today is about multi-agent systems, right? And this is where the real complexity comes in, okay? I have a video. I don't know if I can, how well this works. Let me see. So firstly, let's define what is a multi-agent system, right? And a multi-agent system is basically a set of agents, autonomous agents, okay, which are operating in what is called a shared state space, right? So how do we understand what is a shared state space? Simply, in simple terms, what it means is that the actions of one agent will have an impact, collateral impact on other agents, right? And so I may expect some payoff, but because of how other agents are acting, I may not get the payoff, what I'm expecting, right? I may get something else, right? So this is what is called shared state space, right? And there are a class of multi-agent systems like say swarms and so on, where there's an overarching purpose, right? Like a drones, right? So set of drones coming together, and there's one central coordinator who is coordinating, and the drones are flying around and doing performing an overall task, which is fine. Which means that even though each agent is acting autonomously, there is an overall purpose towards which they're all working. They agree. Okay, that is still simpler. Okay, but multi-agent systems in general need not even have an overall purpose, right? For example, traffic, right? Vehicular traffic on a road network, it's a multi-agent system, and each agent is pursuing its own goal. There's no overarching goal, right? And they may not even agree on what there could be conflicts of interest. No, I want to go here, somebody else wants to go there, and so on, right? And so those kinds of systems become really complex when there are multiple autonomous agents, which are operating independently, right? And so here's a quick video just to show a multi-agentic problem in real life, which has happened. Let me try and open the YouTube link, which may be simpler. Okay, I think you can skip this.
Still, the audio is. Still, audio is not.
So I can probably stop here in this. I guess you got the point, right? The idea here was, oops, was there no audio? Maybe I'll just explain what happened in the video over there. So this is a real life situation where so Waymo is this taxi service in San Francisco, which uses autonomous cars for their taxi systems, right? And these cars are quite sophisticated. They can actually park by themselves without a driver, right? And they have a really good logic to understand the environment and make a strategy and a plan and go and park themselves, right? And they work perfectly well when they are the only car around. Okay. The problem comes when there are multiple such cars trying to park themselves, right? So they get confused and they get into a quagmire, they get into a gridlock, and they're not able to come out of it. And finally, if they can't come out of it, they honk. They start honking it. So each one of them get into a gridlock and start honking. Right? And so this is a classic issue of multi-agent systems. That is, when every autonomous agent is trying to pursue its own self-interest, what happens to the collective? Will the collective be benefited? Not necessarily, right? So self-interests can often collide with each other. They can often conflict with each other, and then get into this. Right? So this is a classic example of the multi-agent problem that many of us, I have been at least teaching multi-agent systems for more than 15 years now. So, I was saying that, okay, you eventually get into such problems. So we are finally getting there. That we are actually having the problems that we were working on. Right? But of course, having cars honking at each other is an irritant, and which can probably set apart. But maybe you may think that that's not such a big deal, right? I mean, so what? There's a little bit of issue with the cars trying to park themselves in. But multi-agent issues go much beyond this. Oops, multi-agent issues go much beyond this into very serious, realms as well, right? So here are some examples. So this one here is a news story from 2016. So it's already 9 years ago, right? And so where this incident happened in Dallas, where there was a suspect who was engaged in a gunfight with the police, right? So the suspect was clearly showing an intention to fire at the police, and the police basically used an autonomous robot to pursue this guy and kill him, right? And the robot went and killed this guy. Now you see, this kind of multi-agent interact, for example, there are lots of AI drones that are being used in Ukraine. It's already there. There's so many YouTube videos or social media videos going around where there's a drone pursuing a soldier. The soldier tries to hit something or and tries a lot of things. The drone, he can't hit the drone. Finally, he gives up, but still the drone kills him, right? And now these are really deep questions to ask, right? And so even a worst, even a hardcore human killer, for example, will have some hesitation when he sees that the other guy is not fighting anymore, he's giving up, right? In either of the cases, when the person saw that there's a robot coming to kill them and they give up, the robot doesn't understand that this guy has given up, or this guy has kind of is no longer a threat, and so on, right? And so humans, we see that we work at several different layers, right? This robot has a goal that it has to kill, and it kills. That's it, right? But for us, it's not just the goal, right? There's many more layers to our rational decision making, right? And we often see that as humans, even if we are successful or even if we are victorious in a warfare, it will still traumatize us. After we come back, we're still affected by whatever actions we do, right? And but none of these happens for AI, right? And so this kind of danger is already there, and it's real, right? And so we don't know what kind of a future this can get into, right? When we have multi-agent interactions, and we don't have the same level of, we're not really understood ethics or responsibility and so on, right? Of course, there's a lot of work in the field of responsible AI, and I'm sure many of you have seen this picture, the well-known trolley problem, right? And yeah, but trolley problem is all fine. So what's the trolley problem? It's basically presents to you a moral dilemma where you have where there's a runaway trolley going on a track, and if you let it go, it will kill 5 people. But if you turn a lever, it goes to another track where it will kill only 1 person, and where will you turn the lever, and so on. And some people may say, utilitarianism kind of this thing. Okay, more people saved is better. And then the question will be, okay, that 1 person is your relative or whatever, is your son. Okay, then will you pull the trigger? All kinds of variations of this trolley problem exist, right? And now these are really deep problems. Even humans find it hard to resolve. And I don't think we'll get an answer for AI for all of this earlier, right? However, there are many cases where it is clear what is a responsible behavior, right? In the human society. But can AI still recognize that, right? So that's the question. So responsible AI, the way we are looking at it, is it's kind of a subset of the overall problem of AI ethics, where we are looking at pragmatic, practical problems where of the responsibility dilemma. I'll define that in a moment. Yeah, and just wanted to add this one more slide as well. So recently I was talking to the lawyer community in another talk recently, and primarily they are looking at how should a legal framework look like for responsible AI, responsible autonomy, and so on, right? And basically what I was arguing is, see, throughout history, there have been two things that we have assumed when we created regulations, right? One is we are creating regulations for people, right? And all people have some common notion of humanity, right? So some common God-given rights, okay, right to life, right to liberty, whatever, so some Bill of Rights and something like that, right? And all humans have some conscience, right? So we sometimes ask questions like, should punishment be a form of retribution, or should it be a form of reform, and so on, right? And because we know that humans have this humanity and so on, right? And, but robots have nothing of that sort. AI does not do things out of spite, out of revenge, out of love, hatred, nothing, right? So all the complex things that go into forming ethical dilemmas for us, robots have nothing of that sort. Okay, yet its actions create ethical dilemmas, right? It can create. So how do you fix responsibility? How do you fix liability? Right. So this is a very different problem altogether. Right. There's a paradigmatically, it's a very different. So I call this non-symmetric equivalence. Right. And so it's something like a person is looking into a mirror. And we see a reflection, but so reflection represents us, right? But a reflection is not equivalent to us. That is we can exist without a reflection, but the reflection cannot exist without us, right? And so same thing with AI as well. That is, we have to work in a way that, we can exist without the AI, but not in a way that AI can exist without us, right? So that's the guiding principle that kind of looking at. Yeah, so just a few slides on how a lot of governments and institutions are looking at it. Of course, now AI regulation is a big thing everywhere. I'm sure many of you have heard of the EU AI Act, which has been legislated. So there's a very comprehensive act, primarily based on, it's not based on applications, it's not based on type of AI and so on. It's primarily based on the risk and harm that a particular kind of AI can provide. So there's something called a harms taxonomy and so on. And it also connects with GDPR, the General Data Protection Regime, and IP legislation and so on. There's also, US has its own Bill of Rights, which is coming up. The Biden administration laid out some principles. So primarily, these are the principles: safe and effective systems, algorithmic bias detection, data privacy, and so on. Now we don't know how this will go after the change of government in the US, but I'm sure that there will be some kind of regulation that coming up. India is also starting with something called India AI Mission. And recently there was a call for inputs for what kind of regulations we need to make and so on. China is also doing something. So world over, a lot of governments are working on AI. There's a good paper which summarizes many of these. There are many companies also looking into drafting their own responsible AI frameworks. Microsoft, Google has already released many open classrooms on responsible AI. Accenture has done something. There's even a Responsible AI Institute coming to, which is a non-profit organization. IBM has its own AI ethics initiative. So quite a few companies and states and non-profits, they're all coming together to this, right? And so here are some online resources. I can make these slides available if anyone wants to look at this in more detail. Yeah, so coming to our issue here, right? Here what we are looking at is not just responsible AI in general, which is of course a very big task, which includes data privacy and data security, the LLMs, and all kinds of worldviews and politics and culture. Everything matters for the AI ethics problems, larger AI ethics problem. We are looking at multi-agent ethics, right? That is agentic AI. When they are interacting with each other, what happens, right? And my reference is this loop that I talked about. So currently we look at agentic AI like this. If we bring in all possible elements that have gone into building agents, so we have beliefs, we have self-interest, we have constraint satisfaction, we have strategies, we have RL, adaptive, reinforcement learning, we have belief revision. All of these, if we bring together, we kind of get a loop like this. Okay, but here one thing to note here is, in all of these, you see that the self-interest remains constant. That is, that is the tagline for this talk as well. That is, who we are remain constant, but what we do keeps changing, right? Our self-interest remains where it is, but what we do, how we pursue our self-interest keeps changing depending on so many considerations and so on. Okay. Now we are going to ask that question. Sorry. Oops. In our work, what we are basically saying is, no, in fact, if we are to talk about ethics, we should really talk about who we are as well, right? And so there's a transformation that goes on inside us as we pursue our self-interest, and the transformation that goes on inside us contributes to our sense of ethics over time, right? And so I'm going to try and make this case here. So to start to make this case, how do we? This can get really deep. So what I'll do is I'll try and give the broad picture of what is our research in this area, right? So how do we kind of firstly formally define what is the responsibility dilemma, right, in autonomous agents? Okay, so primarily responsibility dilemma in the simplest sense presents two choices. Okay, so I'm just calling it C and D, cooperate and defect. So this is the well-known prisoner's dilemma. Again, I don't have the time to go into the details of what's the prisoner's dilemma, but basically what it does is it presents two choices. Okay, one choice is is cooperative, that is, it is ethical, it is responsible. Okay, and if let's say there are two players, if both of them cooperate, they can do well, they get a reward. Okay, 6. Okay, but as long as one player is cooperating, there is a tendency to act irresponsibly by another player, right, which is the defect. So by defect, they get a better choice. Okay, for example, let us say freeloading. Okay, so as long as others are paying the tax, I won't pay the tax, but I can still use all the infrastructure, everything, right, and things like that. Okay? So there's an irresponsible choice that will lead to better utility, right, better payoff. But this will work only as long as the other player is acting responsibly, right? When both players act irresponsibly, we see that nothing works, right? The entire system collapses, right? And so this is a responsibility dilemma. That is, we are presented with a dilemma where there is a responsible choice. It may pose some cost. It may also pose some risk, right? Because others can exploit us. But if they don't exploit us, we are all better off. If everybody acts responsibly, we are better off. Okay. And there's an irresponsible choice which poses a temptation, that is for self-interest, and it gives us a good payoff. But if everybody takes this, then the whole system, is worse off, right? So this is what we call the responsibility dilemma. Okay, and if you take a course in game theory and so on, this is one of the most widely studied games, right? Because it's a very stubborn game. You see that no matter what strategy you use, no matter what there is no real incentive to cooperate at all, right? So if I want to act cooperatively, or if I want to act responsibly, and that poses an extra overhead on me, and that puts me into risk, why should I act responsibly, right? And so that's the dilemma we face in real life as well. Why should I act responsibly, right? And there's an entire book, Robert Axelrod, called The Evolution of Cooperation, where there's a very beautiful theory of how cooperation actually emerges, a mathematical theory, using evolutionary game theory and so on. Okay, but that's a much bigger, it basically says that cooperative societies emerge over several epochs of evolutionary changes of beliefs and strategies and so on, and finally it reaches some kind of civilization, right? That cooperative works. Okay. Now let us see, for day-to-day activities, how have people tried to imbibe responsibility into this prisoner's dilemma case, right? That is, how do we make agents responsible? Okay. So there are several philosophical schools of thought. I'm just putting a few of them here. which guide how to make agents act responsibly, right? And for example, reciprocity is a well-known school of thought, right? Reciprocity is a principle that treat others as you would like to be treated, right? So basically, you don't want to be treated badly, therefore you also shouldn't treat others badly, right? So that's the reciprocity principle. That kind of. Then there's deontics, right? Deontics basically tell that. First, figure out what is expected from you in this role, right? You're in this context, you're playing a role, right? So let's say you're a teacher and you're facing a challenge. Then you have some dilemma whether you can do this. Now, first, understand what is expected from you, right? And then do that, right? So that is when you act responsibly. Third is consequentialism and utilitarianism and so on, right? And so consequentialism basically talks about understand the consequences of what you're going to do, right? And based on that, check what is the collective utility, right? So try and work in a way that the collective consequences are good. The collective utility is maximized, right? So that's another thing. And finally, we have principalism and virtue, right? Approach to ethics, right? Where primarily you say that you uphold a principle, right? So let us say honesty is a virtue, right? So there's a slight subtle difference between principalism and virtue. Virtue is about the agent, while principalism is a principle that we manifest due to our actions. And but primarily the idea here is like this, okay? Through my actions, can I manifest a certain virtue, right? Can I act honestly regardless of the consequences? Can I speak the truth regardless of the consequences, right? So uphold the virtue. So if you are told that speaking the truth is a virtue, speak the truth. Doesn't matter what payoff you get, right? So these are different approaches, right? So I think there's an example also here. So very quickly, let us say we have hope we don't get back there, but recently we had the COVID pandemic, and let's say there is a doctor. And the doctor is, now people are being asked to stay at home to be safe, but doctors are asked to come to work, right? So now the doctor faces a dilemma, right? So if he stays at home, he'll be safe, and he won't. It's good for the family and so on, less risk. Okay, but if he goes to work in the hospital, there's greater risk. He might catch COVID, he might get something, but it could also result in greater good, right? He may save a lot of lives, right? And so this is a dilemma again. So I think, should I stay at home? Should I go to work, right? And so consequentialism basically says, what is the collective benefit that we get by staying at home versus going to hospital? Where is the collective benefit higher? Do that. So utilitarianism says, how many lives will you save by staying at home versus by going to the hospital, right? And so you use that as a principle for change. Okay. Deontology basically says, first understand what is expected of you as a doctor. As a doctor, you need to serve patients. That is your primary, something like that. So understand what is your expectation and act like, and so on. Virtue ethics, rational, and so on. So that's So these are different ways in which we look at this, right? But in all of this, what is the issue here also is, now we see that ethics is being seen as a layer on top of rationality, right? That is, we build a machine and then we put ethics on top of it. Okay, we build an ethics layer into this, right? And so all of these layers, and ethics typically is built as a constraint layer. That is, if the ethics layer were not there, I will do something. If it is there, I'm more constrained. I'll act more civilly, right? And yeah, there's also another. I don't know how much time I'll have if I go into this, but this whole idea of machine hermeneutics, right? See, over the last couple of centuries, much of our design of machines have completely ignored any such questions like ethics and agency and such things, right? We never talked about agency and ethics when we built steam engines or airplanes or whatever, right? And only in some part there'll be something called human factors, somewhere in small and So this is what I call machine hermeneutics, right? Where we are so programmed to think of technology as a machine, purely in terms of processes, right? And so I keep telling my students, that see, suppose somebody goes to a lawyer and says, my friend has cheated me, right? And the lawyer asks two questions: why did your friend cheat you, and how did your friend cheat you? Right? Now there are two different questions, right? So why talks about what is the motive, what is the what is the intention, all kinds of. How means what was the mechanism, and so, right? And so there are two different questions. We know that clearly, okay? But suppose you go to a scientist and ask, why do eclipses occur and how do eclipses occur? You see that you'll get the same answer, right? Why do eclipses occur? Because there's no question of agency, motive, intention, anything in the physical universe, right? And this is what I call machine hermeneutics. And this kind of thinking has permeated so much, even in our understanding of human interactions as well. So Rene Descartes, right, who is well known for his I think, therefore I am, he basically he has said this, I have described this earth and indeed this whole visible world as a machine under the spell of mechanistic philosophy. Even animals and human body are basically machines rather than living organisms, right? And so we're so focused on the mechanics of something, we are not giving enough credence to the agency part of the whole thing, which is where ethics come into play, right? And that is where we are arguing that if we really want to talk about ethics, machine ethics, we have to really talk not so much about what is it we are doing, right? How to do something, what we are doing, and so on, but more about who we are, right? Who is the agent here, right? And so what is the agent becoming as a result of its transactions, right? And so this is what our argument is. I'll give another quick motivating example. I'm spending a lot of time just in the motivation here, because once you get the motivation, the rest of the mathematics would be simple. We can always share the papers and we can go through this. But once we get the motivation, this, okay? So I'll give you one more motivation. Okay, so this is I'm just using a bullock cart as an example. This was a story narrated by my grandfather, during his time in a village in the 1920s or 1930s. At that time they didn't have cars or anything. Basically, people used bullock carts, right? And so there was a neighbor of his in the village. He took all his farm produce to some nearby town to sell them. So he sold them, made a lot of money, and he was coming back, okay, in the night. So again, it was dark, there were no good street lights or anything. And while he was coming back, some robbers attacked him, right? And they basically hit him. He became unconscious and didn't know what happened. But when he got up, he saw that he was at home, okay, and then he realized that the bullocks which were pulling the cart had actually, they were not attacked, only he was attacked, okay, but they had actually fought with the robbers and ran home with him and brought him safely, right? And now, which autonomous car today can give us this level of safety, right? And this is what we mean by, okay. So now the question is, what kind of training did we give those bullocks? Was it RL? Was it reinforcement learning? Was it auto regression? Was it supervised learning? They were not even given. They were not even exposed to even one situation where such an incident had happened. Somehow they developed so-called common sense to see what. Okay. So are the bullocks kind of doing this mathematics in their head that, oh, this is the guy who feeds me, and if he gets hurt, then I won't get. I don't think they're doing anything of that sort, right? And so basically, what is happening behind it, right? There's also one more saying from Ashtavakra Gita. It will take a lot of time for me to explain this, but really, Ashtavakra Gita 2.2. Just have a look at it. This is one little. So what it says is like this, okay. As I become aware of the world outside, okay, so you can see the world outside, there's a computer in front of you, there's a room, I become aware of the world outside, okay. And let's say you can become aware of the world inside you, right? The thoughts, the emotions, the aches and pains that are going on, right? Now, what it says is, I don't do anything different to become aware of what is outside and become aware of what is inside, okay? So why do I call this body mind as me and the outside as not me, right? Either I'm everything or I'm nothing. So that's what it says, okay? Atava mama jagat sarvam atava na cha kinchana. Therefore, I am everything or I am nothing. Right? So what I'm trying to get here is this whole concept of an elastic sense of self, right? So what we are trying to say here is, see, our sense of self or who we are does not end with our body mind, right? We actually attach our sense of self to several things around us and act as if they are also part of us. Right. So in this case, what has happened is, the bullets thought that they were part of a family, right? So the guy here is also part of them, right? So if the guy is attacked, the person is attacked, it means that they are attacked, right? It is equivalent to saying I am attacked, right? And so they were actually saving themselves. Right, so because the person is also part of me, right? And so this is the basis for all our, let's say, family relationships and or identities, community identities, religious identities, national identities, right? All of them happen because we identify with certain things. Okay, we identify with our family, we identify with our children, we identify with our country, with our community, whatever, right? And that means we attach a part of our sense of self and we act as if we are that, right? So if, let's say, you're watching a cricket match and, India won against some country and people are distributing sweets on the road as if they have won the match. They didn't play the match, but India won the match. That means they have identified with the country. Right, and so it's as though I have won the match. So I'm being more generous, right? And it's like that. Okay, so our sense of self is elastic, and that elastic sense of self changes our self-image, right? And that we are arguing is the key for our sense of ethics as well, right? Our sense of responsibility and ethics, right? And and of course, here is the little bit foray into the mathematics of it. So let us say, typically, okay, we identify very closely with body mind, right? Our body mind. So our body mind, if you say, where are you? This is me. And so now you see where the Swamiji's talk is coming into this thing, right? And we keep saying, where is I? And so on. And so we typically point at our body and say, this is I. And so, okay? Because we have identified with it. Okay. But it doesn't stop there. We identify with something beyond as well. My family, right? That means, that's part of me. Okay. So my community, my country, and so on. Okay. So I was also telling my students recently, see, if you think your parents are not acting rationally, be thankful. Okay. If they acted rationally, then there's no incentive for them to take care of you, right? Because bringing up a child is very costly and very risky. Right, so if I'm a pure rational agent, there's no incentive for me to bring up my child, right? And I have to identify, I have to my sense of self has to include my child, right? And that's when I can actually bring them. So that's the idea here. Okay? So then I will not go too much into the mathematics so that we can actually have some. So this is so how do we do that in agents, right? So how do we build agents with an elastic sense of self, right? And long story short, what we do is we have two parameters. One is what is called the elasticity, which is what we call gamma, and another is what we call attenuation, which we call distance, right? And we say that our sense of self contains several identity objects, including myself, that is the agent itself, okay? And the agent identifies with a distance gamma to the d two different objects, right? And this is a normalizing factor. So basically it normalizes to 1, like this, right? And so for example, if I say gamma is 0.3, which is somewhat elastic, and I identify with my body mind, my family, my team, my country, the world, the environment, and so on, Now, this is how my sense of self will look like. That means my happiness or my utility comes from 70% based on what I am earning or what gains I am getting, 21% based on what my family is gaining, 6% based on what my team is gaining, like this, right? And so all their utilities come to form my utility, right? And if I increase my elasticity, this thing changes here, right? So my self-image also changes, right? And now we show that this little thing called the self-image can bring a lot of versatility in the way agents act autonomously, right? And so we come back to this famous prisoner's dilemma, and then we say, okay, each player now identifies with the other player with some gamma. Okay, so where I say d equal to 1, and with some gamma where we change the gamma, which is the elasticity. Okay, and then we compute what is the expected payoff, okay, of choosing a responsible choice versus choosing an irresponsible choice, right? And here is the output for this. So when gamma is 0, that means I'm not transcended. So this is what we call transcendence of identity. So if I'm not transcended, then E of D, the expected payoff of acting irresponsibly, is more than the expected payoff of acting responsibly, right? So that means it makes more rational sense to act irresponsibly, okay? But as I increase my elastic sense of identity, we see that this flips over. In fact, at gamma equal to 1, E of C was where E of D was earlier, right? So the game exactly flips over. So with complete empaths, for example, okay, prisoner's dilemma presents the exact opposite opportunity, right? So it doesn't say what is the dilemma between cooperate and defect. The defect is not at all a temptation, right? Because the cooperation is a temptation here, because I'm factoring your payoff also as part of my utility in this. So, and we showed that for different games like this. This is what emergence of cooperation, and we also took this Dallas shooter model, that there was a robot which was sent to kill a suspect which was there. So we drew a game like this, and we showed that if the robot were not transcended, which was the case currently, it would make rational sense for the robot to attack the suspect rather than retreat. Okay, but if it is transcended, then it will be much more likely to retreat or negotiate, especially when the suspect also retreats, right? And so this is the kind of output we got for if the Dallas shooter had been endowed with this transcend. Similarly, we tried for several others. So this is actually a 3-player game with what is called collusion, right? So collusion results in multiple levels of identities, right? So even in societies, for example, we have a communal identity, we have a national identity, all kinds of things, right? And and oftentimes, so in this game, what it shows is that oftentimes a smaller subset can collude and get a better payoff at the expense of the bigger rest of the society, right? And so this is so there are 2 kinds of identities here. So do I identify with, or rather 3? One is, do I identify with just myself, and with my community, and with the country, right, or with the nations? And we show that as long as I am having the country in my identity set, as long as I'm identifying with the country, it doesn't matter whether I identify with my group first before the country or the country before the group. As the transcendence levels increase, we'll start acting responsibly, right? And so as the transcendence levels increase, we kind of reach the same rational conclusion, right? And yeah, so this is the theory. Then what we did was, okay, now how do we kind of operationalize it, and how do we kind of put them into practice and so on? So then we created a framework, which basically a multi-agent framework where some things are getting exchanged. So let's say we have a graph like this, and in this graph, of course, each node is an agent, and a node can play 3 roles, one of 3 roles. It could either be the sender of something, the receiver of something, or an intermediate node, which is forwarding packets, right? And So the intermediate nodes are where the responsibility dilemma comes in, right? So that is, if I forward a packet that belongs to somebody else and is going somewhere else, then I incur a cost, but I don't get any benefit, right? So there's no incentive for me to forward a packet. Okay, but if nobody forwards, then none of the packets reach their destination because somebody in intermediate has to forward it, right? And so this is the thing we got, and then we showed that, and this is the payoff matrix. I won't go into the details. We can again go into that, and how we compute the rational choice from here we make, and after that what we do. Okay, so we keep forwarding or not forwarding based on our transcendence level. But one more thing we note here is again responsibility offers a risk, right? That is, if we act responsibly, others can exploit our responsible actions, right? And so if we say that I'm going to act cooperatively because I feel good for you by your success, others may say, okay, keep acting for me. Okay, so you are suffering yourself, but you are feeling good for others, right? And so there's always a risk, right? So that comes back as a reinforcement signal for us here. And then what we do is each node will curate its semantic distance, right? So I say that, okay, I do care for you, but not so much as this guy. Okay, I care for this guy much more than you, kind of, right? And so it kind of curates its semantic distances based on the reinforcement signal it gets, based on how my work was reciprocated or not, right? And we see that this is the output we see. So we see that with increasing transcendence levels, there is a slight increase in cost because we are acting responsibly. That means we are expending resources. Okay, but there's a much bigger increase in total utility or total payoff, right? So because now each one of us acts responsibly and incur a slight cost, but overall we are much better in this, right? And if we just look at the cost, this is how it looks like. It looks like acting responsibly is very hard because there's a big increase in cost. But if you compare the cost increase with the utility increase, we see that the utility increase is way more than the cost increase. And yeah, this is how the network itself performed. So these were the number of dropped packets. 80% of the packets were dropped when transcendence was 0, while just with the transcendence of 0.4 or more, 100% of the packets were transmitted. 0% were dropped, right? And so it actually resulted in a much better overall output. Then we also tried an evolutionary version saying, earlier we were setting the transcendence level, transcendence equal to gamma equal to 0.2, 0.4, 0.6. So then we said, can we get the agents to discover what is the best gamma for them, right? So we introduced one more evolutionary component to this. I won't go into the details again. And we actually saw that as the agents discovered their own transcendence levels, okay, the difference between their own transcendence levels where they settle down is reducing, right? And we get almost 100% utility very quickly, right? So this is and we also showed that. So suppose I infuse this network with some adversary agents, right? So adversary agents means which are just rational agents, right? So they'll just exploit. If somebody is acting responsibly, then I'll exploit, right? And so here we see, especially with the evolutionary component, even with, let us say, 50% of adversaries, 0.5, okay, and we still get in the yellow or blue region. That is, all the yellow and blue means that my f minus d by f plus d basically stands for how many packets did I forward minus how many packets did I drop, normalized by total number of packets, right? And so if it is 1, it means that I have forwarded all packets, and if it is 0 or minus 1 means that I have dropped all packets, right? And so we see that the yellow and blue is a good this one, and so even with quite a large number of adversaries, the network is resilient. The network is able to perform. Yes, so that is very quickly about this. So I'm aware of how we are going on time. So I'll kind of briefly touch upon some of the simulations we did for, say, supply chains. So the earlier one was a framework, but we actually, I think, as part of Nikita's thesis, we looked at flow networks in terms of supply chains and logistics and so on. There we had to have some variation of the prisoner's dilemma called the continuous prisoner's dilemma and so on. And here again, the intermediary has this dilemma, right? If the intermediary ships all the packets as soon as they come, then the network will function very efficiently. The delays are low, but the intermediary incurs a lot of cost, right? Because every time he has to get a van, and then this van will take only one product with it. So the intermediary wants to wait and collect more and more orders before shipping, right? So, but more and more the intermediary waits, the more delays you have, right? And so when should I call the shot? When should I dispatch, or when should I wait? So that's the dilemma that we are having. And we again compared it against other kinds of, for example, the adversary here is a selfish agent which just wants to minimize its cost. Then there's a virtue delay agent who is told that minimize delay no matter what. Even if you incur a loss, you minimize delay, right? So this is the other extreme. Well, this is one extreme, and this is our transcended agent, right? And so we actually see that even with virtue delay, even if we tell an agent saying that uphold this virtue no matter what the consequences, okay, we see that the total average delay per order, right, is much lesser with high transcendence level. With low transcendence level, of course, virtue performs better with transcendence 0.1, but with just transcendence 0.4 or 0.9, we see that it is outperforming even virtue, right? So you have programmed an agent to be selfless and then say, minimize delay no matter what, but still it is actually having more delays and less utility and more cost, right? And so of course, transcendence has slightly more cost here, but the delays are actually much lesser with transcendence, right? And so that is one. So we also applied it to another scenario of autonomous traffic lights. So we already have such traffic lights coming on in several intersections. Now each traffic light, what it does is it looks at the amount of queue in its intersection, and based on the queue length, it adapts the time it takes for red or green or whatever, right? But then it optimizes for itself, okay? So, but because I am optimizing for itself, downstream, I may be causing problems, right? And so that's the problem that we are looking at, right? And so if I have a grid like this, if I let go of all vehicles here, they may all come and clog here, right? And so can transcendence help here in this case, right? And again, we looked at several different heuristics that the adaptive traffic lights are using. And again, long story short, I won't go into the details here. We see that if I have a traffic light that is changing its timing based on maximum queue length or maximum wait time, okay, so these are the heuristics that are currently used, right? So see whichever part has maximum queue length, you give that priority and so on, okay? But even there, we see that transcendence performs much better. The average vehicular speed is much more. That means the wait times are much lesser, right? And so average vehicular waiting time is much lesser in transcendence as well. So that's about it. Then we also compared, this was Janvi's work, so we compared with different paradigms of ethics. So we basically created this multi-agent framework and said, okay, transcendence is one, then I'm going to have virtue, then I'm going to have utilitarian, I'm going to have deontics, reciprocity, all kinds of different models, give them the same dilemma and see how they work. And then even make a mix and match, suppose I have a mixed network. How does it work? So all those things we did here. So these are all the different, and of course, adversarial, which is the selfish agent. So we looked at all of them like this, and you can I can share the paper if required. So again, we see that the overall utility in transcendence is slightly higher than all of this, and burnouts. So burnouts as well, acting responsibly does pose a cost, right? So if agents keep incurring cost after cost after so long, we have a burnout threshold. After that, they'll get disillusioned, saying, "I'm not going to act responsibly," right? And we saw that average burnouts is lower here, and the utilitarian burnouts are much higher. Virtue burnouts are the highest, right? Because virtue agents are said that act responsibly regardless of what you get, right? And so their burnouts unsurprisingly are the highest in this, right? So this is where what we got. So this is a quick summary of the kind of work we said, and I'm going to skip this in the interest of time. Burnout thresholds as well. Okay, so that's kind of more or less what I have to say. That primarily, we are currently agentic AI in the implementation part, to the best of my knowledge, is not anywhere close to this. Agentic AI currently says, if you give a prompt, I'm going to break it down into tasks and perform it, right? And recently, I even saw some articles saying, I'll program my agentic AI and you program your agentic AI, and our agents will start talking to each other, and we don't have to do anything, right? This is not something new. In fact, I heard the very same rhetoric almost 30 years ago, right, when algorithmic trading came. Right? So I'll tell my trading agent what to do. You tell your trading agent what to do. It is there. It's working. In fact, algorithmic trading is a thing. But of course, that hasn't obsoleted human traders. Humans are still trading, right? And so I think there's much more than agents talking to each other. There's a lot of questions of ethics, responsibility, and more importantly, what we are saying is much of responsibility dilemma is being sorted out with the question of what to do, right? But we are saying that primarily we should be asking, who am I? That is, how am I transforming with all of this? And how should I curate my sense of self, right? And that is what makes us act towards versatile situations, giving us these responsibility dilemmas. So to conclude my talk, I will just give one quote from Ramana Maharshi. So apparently somebody once asked him, how should we treat others, right? And our usual says, treat others as you would like to be treated, right? Do unto others as you would have done unto you, right? So this is a reciprocity principle, okay? But Ramana Maharshi said something interesting. He said, there are no others. So they're all you, right? Once you transcend fully, right? They're all you. So where's the question of treating others? Why would I spite my nose to whatever? Why would I cut my nose to spite my face or whatever? Because they're all me, right? And, so that's the that's the spirit behind the whole. So these are our publications, and of course our sponsors. We've got sponsors from our Machine Intelligence and Robotics Center, Center for Internet of Ethical Things, also in IIITB. That in turn was funded from the Karnataka government as well as the World Economic Forum. So our immense gratitude to all of us. So thanks once again, and I'd be happy to answer any questions.
Thank you, sir. Thank you for the wonderful session. Sir, there are a few questions in the chat box, and also during the registration, some of them are asked. Am I audible, sir?
Yes. So shall I take up some of the questions from?
Yeah, I hear that there is a question from Mr. Govind Srinivasan. Wonderful presentation. I hear that the existing SaaS model may become obsolete in the wake of agentic AI, making it steady inroads.
Yeah.
So, is it already making the impact?
Yeah, very good question. And yes, I would say it is making an impact. In fact, already we are seeing so many of the traditional SaaS services being replaced by AI services and even agentic services, one or more, right? And there is quite at least for the routine things, like say creating a presentation, sending a mail, all those little less risky things, right? They are more likely to get taken over by AI, right? For the more riskier things, I'm sure the regulations and so many other checks and balances come in. So that may not really, if I have to scale or if I have to, do some systemic work, that may not really get impacted. But the routing things, that it is looking very much so.
Sir, can
Thank you
you
very much.
put on your camera on, sir? Camera on.
Yeah.
Dr. Srinath. Yeah, camera on. Camera on.
Do you want me to switch?
Camera is on. Can you
Yes,
switch
sir.
on the camera? It's
He's
on,
on.
is it?
It
He
is
was on only.
Okay,
Yeah.
okay. Because I'm only seeing the icon.
Okay, okay. No, he was on. Two things are there. One is his presentation, sir.
No, presentation is okay.
Hmm. So there are some questions during registrations. If you want, I can take up some of them.
Yes, sir.
Yes, sir. You yourself
uh,
can pick up, sir. Ma'am, let him pick up the questions and reply.
Okay, ma'am. Okay, ma'am.
Sure. Yeah. So there is this question by Afshaq Ahmad and Khalil Rahman, they're students. They're basically saying, a very good question. I thought, they're saying by this whole concept of AI, you're making AI more human-like and in a sense, more fallible like humans, right? So will they not create as much trouble as humans themselves are creating? How do you strike a balance between AI having autonomous behavior and obeying something? Good question. Yes. Firstly, why are we doing this, right? Why are we creating autonomous AI in the first place? Do we really want to make AI more human-like, right? And the answer really is that as AI is taking on more and more complex problems, right? Like say driving on the road, right? It's very hard to put in a set of rules a priori and say this is how you drive, right? And not adapt, not learn, and so on, right? And so the autonomous agent is coming in because the nature of the problems we are addressing is getting more and more complex, right? But then the agentic model is also getting more and more human-like, right? And which means that humans are actually created to address very complex problems, right? And but the question really is how do we make machines do what they're meant to do? That is, that they have to obey us in the sense that they have to yeah, correct. See, that is where we have to have it can't be just an autonomous. We need to have constraints. So this is the so I was giving this that loop which I was telling, right? Where there are external constraints, where there are so where I'm just going back to that. Where is that? This loop here, right? So all these elements are still important, right? The constraints that I put in, right? The strategy, the belief system, and so on, right? So it may do a lot of adaptive autonomous activities, but then it should also be guarded with some really strong guardrails. That is where the constraint systems come, right? So that's how we kind of balance both. Okay, and there's one more question. How can we leverage AI in healthcare and food industry? Primarily, of course, we already are seeing AI in different kinds of applications, both in healthcare and food. But in both of these, the risk taxonomy is kind of on the higher side, right? And so, can I use AI to prepare my food for me? In principle, yes, but the risks are also higher, right? Can I use AI to diagnose? People are already doing that, right? People are already asking ChatGPT, giving their symptoms and saying, okay, tell me what is the problem, and so on, right? And the risk is high, right? And so in both of these industry, the guardrails have to be that much more stronger, in addition to what we have generally. There's one more question that talks of how to ensure ethics of AI in terms of agentic workflows and multi-agent systems, and how can we reduce the cost of GPUs? Yeah, big questions again. because our biggest problem now is with the computing GPUs itself, right? And one, of course, I will probably skip the first question, which I hope I have kind of addressed in my talk, how to ensure ethics of AI. We looked at different ethical paradigms and philosophies and so on. So regarding the second question, how to reduce GPU cost. So this is something I was arguing recently also, right? So DeepSeek, for example, has greatly reduced their GPU cost, right? And there are some articles that are coming around which says that DeepSeek has kind of modularized their entire foundation model, so that for every question you ask, the entire trillion parameters are not at work. Only a small part of it is at work, right? And so they've used some clever techniques to understand for a given prompt which part of the transformer will be used, and only use that part and not to others and so on, right? And so there are actually clever hacks like this. In fact, I would say I won't even call it hack. In fact, in order to really bring this down, what we are currently doing is basically a brute force, right? Add more, throw more hardware, and do everything in a brute force fashion. There can be some science by which we can modularize how we use, right? And second, what I was also arguing is, if we take the agentic paradigm down to neuronal level, right? If we make each and every neuron in a LLM, for example, agentic, right? My conjecture, again, I have to test this conjecture, that we can get much superior performance for much lesser number of parameters than what we have. So there are big open problems that are very much there, especially for those interested in research. These are very interesting problems to talk about. Yeah, and finally, I think there are quite a few questions. Maybe I'll just take one or two, which again, we are already aware that we are out of time. So one is, there is a question on how to learn AI in my mother language, right? Or how do we kind of make AI more? There's also one more on culture and so on. Is there AI plus autonomy from the view of Indian culture? Are we there? Is there something? Again, this I found to be a very interesting question, in the sense that we were arguing also the other day. If you look at the design of transformers and so on, the base model of LLMs, okay, they are based on what is called the masked language model, right? And which in turn is based on a very English kind of assumption about language structure, what we call lexical language structures. While Indian language structures have very complex forms, there are morphological endings, there are free word order, and so on. And we have been arguing, even recently we had a conference on responsible autonomy, and we are saying maybe we can even rethink the model, the core model of LLMs for Indian languages, by taking into account how Indian languages themselves have a very strong scientific foundation. There is a phonetic way in which we construct letters, and there is a semantic way. The karaka and vibhakti, we kind of create role markers for every word in a sentence, which makes them free word order. Then there's agglutination and so on. So there's a lot of science that has gone into that, and it is, I would conjecture that it is possible that there could be fundamentally new paradigms if we go native in terms of how we are training AI. So that's just speculation for now, but something for you to think of. Okay, so I think I should stop here. This is a very exciting topic for me, so I can go on and on, but I'm sure we all have time constraints, so I'll stop at this time. So on to you, sir.
Thank you, sir. I think Akila, can you start this? Dr. Komathy?
Yes, sir. I will do this. Good evening, all. I thank the organizing units, CSI Chennai, IEEE CS Madras, and ACM Chennai for arranging this webinar today with the topic Responsible Autonomous AI. We sincerely thank Dr. Srinath sir, Professor and Dean, Web Science Lab, Indian Institute of Information Technology, Bangalore, for his excellent presentation on responsible autonomous AI. In summary, today's presentation has emphasized the following. Agentic AI is one which acts as autonomous on its own, follows different models such as self-directed actions, normative models, reinforcement learning models, and rational choice. With the initiation of agentic AI, the ethical challenges of multi-agent systems, MAS, need to be addressed. Responsible autonomy has become a vital concern for agentic AI entering into various applications such as autonomous cars, autonomous drones, autonomous traffic lights, swarm robotics, algorithmic trading agents, etc. Some of the regulations of AI have been highlighted here, and with corporates also involving in it. And Dr. Srinath, in his research work on computational transcendence, it is argued that responsible behavior is not necessarily in conflict with the autonomous choice that our sense of responsibility and ethics is rooted in our sense of self, or who we think we are, rather than on what to do in a given situation. In this work, the authors proposed a mathematical modeling of an elastic sense of self into autonomous agents and showed that even a little bit of elasticity with the agents can result in vast improvements in responsible autonomy. The presentation also highlighted a few applications involving multi-agents, agent flow networks like supply chains and vehicular traffic control, and discussed how to incorporate CT in these networks to improve the flow. I thank once again Dr. Srinath for answering the question raised by the participants, both online and offline. I thank our mentor, Mr. H.R. Mohan, Chair Events, IEEE CS Madras, who worked meticulously to bring eminent speakers for familiarizing the recent trends in computing technologies for the benefit of our members. I sincerely appreciate the participants who joined us in live Google Meet and YouTube live streaming and their active participation in the question and answer section. I thank the event team members from the organizing units for their support in arranging this event. With these warm words, we move to the end of today's event. Thank you all. Thank you, sir.
Thank you.
Thank you so much,
Thank
sir.
Thanks, Suri.
Thank you, Professor.